No, Pawel.
Mariusz. Oh, Pawel? I didn't get any, okay, because I used the Pawel link, but I didn't get any link to this Zoom webinar. Should I have Mariusz? I am Mariusz. Like, should I have
Mariusz.
should I have any other my own link?
Okay, I have no idea what to do right now. I'll just text.
Or I can join using the like the regular one, the regular link, and join, and you can.
Yeah, that's good,
okay.
and I'll give you the
okay.
role. Okay, that works. No, it works. You are already a panelist, so
yes, cool. Thanks.
Okay, and here is Pawel. Hello, Pawel.
Hello,
Hey,
hello.
Pawel.
You can prepare your presentation. You can share the screen, see if everything works. So we can start when.
Okay, and how can I? I should. Okay.
Slideshow.
Review. No, view. Slideshow from beginning. Yes.
Yeah.
And what you see just the slide?
Yeah, I see just the slides.
Cool.
And few things for our attendees. Attendees can only ask questions through Q&A. They can't use chat. If you want to, let's say, share some links with them in the chat, you can send it, but they won't be able to see, so I will copy paste it for them so they can see it as well. Okay, it's just that it's just really strange, but yeah, it works like that.
Okay.
And other than that, during the Q&A session, if you want to, let's say, turn somebody in for discussion, you can tell me and I can give them permission to talk, not only write in the Q&A.
Okay.
Can we change the virtual background or?
I
No?
think you can. It's you see the second icon in navbar. It's video, so you go video settings, and then you have background and effects, and you can add yourself.
Okay, because I have only filters or.
Oh, you have a little plus at the right.
Here. Okay.
It's really strange. I was looking for
so okay, so we can just add, I would say, image from our computer, yeah?
Yeah.
Okay.
How do you have a background for from software one, or what kind of background do you want to add?
No, I was thinking about, yeah. Do you have this background on your computer or?
No.
Okay, because I have only none and blur and plus adding. So okay, no problem. I will go with blurring. Okay. I think that we have. So we will see the questions in Q&A, yeah?
Yeah, as you can see, you have like on navigation bar, you have Q&A.
Yeah, yeah.
So you see open questions, answered question, and dismissed questions.
Okay.
So if you feel, like that you want to answer some question during the webinar, you don't have to wait for the end of the webinar, so you can just mark it as, I think when somebody asks you, you can like answer live. So you just click that and it goes into answered.
Okay, sure.
But I'll be here listening as well, so if you have any problems, you can always ask me.
Sure, I will just.
Okay.
We're starting 1:30, yeah?
Yeah, we start at 1:30, but we'll wait, like, let's say, a few minutes so people gather up.
Yeah, okay, sure. What is a classical distribution between the tutorial and questions, like 15 minutes per question normally, or?
Well, like for the first two tutorials, we had like, I think, 2 questions in the first tutorial, so it was like 4 or 5 minutes. But for the second tutorial, we had like only one guy asking questions, but it was like a longer discussion. So they for like 10 minutes because like they went into discussions, not only answering questions. So yeah,
so it would be good to leave this 15 minutes safe for the questions.
I would say so.
Okay. O, masz tego Software One'a?
No ale mam jakoś odwrócony, że jest nie widać
odwrócony.
napisów. Nie rozumiem, jak mam to poprawić.
Okej, dobra. Tak, zostawimy. A pokaż jeszcze raz, jak zrobiłeś.
No weź zobacz.
Nie, ja widzę dobrze.
Tak?
Tak, no bo po prostu u ciebie widać ten. A mógłbyś mi to wysłać?
No już ci wysłałem na maila. Na Teamsie.
Mhm.
Chcesz ten sam czy inny? Bo ściągnąłem 5.
Ten sam może być.
Yeah. Most.
We'll wait for a few more minutes and then we'll start.
True.
Oh, widać. Cool. So you, Paweł, you will share the presentation now.
Yep, I will start sharing and
Okay, I think we can start now, so you can share your presentation. I'll introduce you guys. Okay, welcome back everybody. Our next webinar will be delivered by Pawel and Mariusz from Software One, and they'll be talking about computer vision in Azure. So as always, if you have any questions, you can write them in Q&A chat and our speakers will answer them. So enjoy this tutorial and yeah, good luck everybody.
thank you very much. Hello, everybody. As once mentioned, we will be talking today about computer vision in Azure, based on several projects that we have delivered. In a moment, I will share the agenda and how we will approach today's tutorial. But to begin with, a short introduction from our side. My name is Pawel Ekk-Cierniakowski. I'm involved in data science and artificial intelligence for over 10 years now. Currently, I'm leading data science domain at SoftwareOne, so the delivery team of custom AI solutions in various industries. And together with me is Mariusz.
Yes, hello, everyone. My name is Mariusz Wiecha, and I am principal data scientist at SoftwareOne. In SoftwareOne, I participate in the development and implementation AI solution that empower clients to adopt cutting-edge approaches to addressing their business changes. And I have over 7 years in data analytics, data science, machine learning. And yes, and thanks SoftwareOne, I can work closely with clients across Poland, Europe, North America, and the Middle East.
Okay, and if you would like to connect with us, feel free to join us on LinkedIn. I think it will be quite easy to search us on based on our names. Okay, so I will start with the agenda of the today's tech tutorials. What we want to discuss will be 3 different use cases of using computer vision. And for each of the use case, we want to present 3 types of information for you. So firstly, going with the business background of the solution. So what was the purpose of the solution, and what was the main challenges, and what has been implemented from the business and technology point of view. The second thing will be focusing on the Azure services, which we will present in the form of studios. So studio is the possibility in Azure to quickly prototyping the solutions using a completely no-code approach. And we will focus on 3 completely different use cases from various industries. The first will be information from the invoice perspective. So we'll be reading the information from invoice. The second one will be sustainable development based on the limiting wasting of food, as well as the proper recycling of the waste. And the third one will be to read the information from the flow meters. The 3 Azure services which we'll present will be the Azure AI Document Intelligence, which previously was known as Form Recognizer. The second will be Azure AI Vision. So all of the I would say custom vision and computer vision solution for in Azure. And the third one, so not to be completely out of the current interest of large language models, will be also presenting how large language models in form of Azure OpenAI, which contains, for instance, the models of the GPT family, can handle with the computer vision tasks. And last but not least, for each use cases, we'll also go through the code, which was written in Python, for you to understand how these services can be used in the real world solutions. Okay, so let's jump to the first example, to the first business case. So one of the customer has a strong issue with reading invoice number, which they want to match with the information in other systems. So to be able to understand and using this information from invoices, they have to renaming the invoice file, the PDF file, with the correct invoice number. Of course, the main challenge for it was that this solution, this I would say manual renaming, was absolutely time consuming, and it was very prone to errors. So the idea was to create the technology, to create the solution that will be reading the information, the invoice number, and then rename this file appropriately to match this information with the system. So it was, of course, the process has been shortened a lot. The accuracy was much higher in compared to doing it completely manually, and also the system can currently handle a large number of invoices. Okay, so let me jump into the Azure AI Document Intelligence to show you how this solution can be quickly prototyping, and then Mariusz will present a little bit more about the approach using Python. Okay, I hope that everybody can see my screen with Azure AI Document Intelligence. So this is an online tool that enables us to explore, to ingest the information from the documents. It can be trained for the custom model. It can be used as the pre-trained models, which will recognize the particular information. So I will start with this this in this task we have the invoice, which is one of the pre-trained models in this service. So we'll start with pre-built models. As you can see, we have the invoices, we have the receipt, we have the identity documents, US health insurance, and a few more. There's a lot of, I would say, US-based documents, but also more generic documents are here to be used. Okay, so I would start with the invoices. We have some samples that can be read here. Sorry, one moment. Okay, so we have the sample of the some invoices which can be read using this tool. So we'll run the analysis. As you may see, this is invoice in English, but later on we'll also use different languages. This has been not prepared, so this is the out of the box model which read all of the information from the invoices. As you may see, we have 3 items, and if we'll go a little bit down, we will see that indeed 3 items has been ingested. We have the content, we have the amount about, we have the date of this, the description, what was this service, product code, quantity, tax, and so on and so on. As you may see, also we have the information about the confidence score. So the model also provides us with the information how confident it is with this information. So whether this information has been read with ease, or rather it can be some mistakes. In most of these cases, we see 90 or almost 90% of confidence. So rather everything should be read in the proper way. As you may see, we have I hope that it's visible. I will put it a little bit. Yeah, so we see the amount due on this. We have the billing address. We have the information about the customer address, and so on and so on. So all of this information from the invoice has been successfully ingested. As I mentioned, of course, this is the invoice is something that is quite similar across various countries. So if we have some invoice in German, it will be also quite good recognized. We have the information also about the customer address. We have the information about customer ID and also the items. So we have these 2 items, which also has been proper ingested. Across the, as I mentioned before, we have several of pre-built models in this area. Also, we have, for instance, the receipts. Receipts are a little bit more complex because, of course, invoices are rather much more similar one to another. Receipts for various stores can differ a little bit, but also on our samples we will see that these 3 items has been recognized, that it was 4 hot dogs, 2 double cheeseburger, and 2 beers. The quantity has been also ingested and recognized properly. Of course, if we have our documents and we want to see how these documents are being read by the system, we can do so from fetching from the URLs or browse from the files, or even drag and drop. I will put one of the item here. So this will be the receipt from the store in Poland. So it's also in Polish, and we will see how this information will be analyzed, also using this out-of-the-box model. So we haven't created this model on our own. We haven't created it for the specific store or for specific language. This is the model which is not trained on our data. As you may see, we also have the information about the items. We have 18 items here, and from we can see each of this name is the item, and each item has been recognized. We have the merchant name, which is Lidl. We have also the tax details, so also such information as tax, which of course, it's very different across the countries. For instance, in Poland, we have several tax rates for value-added tax, and all of this information about what kind of tax, this rate of 23%, rate of 8%, or rate of 5% has been recognized, and here all of this information is provided. So also based on this completely other information can be used. And last but not least, from the Document Intelligence Studio, we have also the classical OCR. So we can use it also for just reading the text from any articles, any information. We can see here that the text has been read into the specific paragraphs, which can be also then used in our system. If we want to use also some barcodes, we can also run this analysis, because sometimes we have some like here the invoice with the specific information, and there is also text that has been read by the engine. Okay, so from Azure Document Intelligence, I think from the studio perspective, that's all. And I will give the voice over to Mariusz to present the Python code that has been used in this project. Of course, if you would like to, if you would have any questions at any time, you can ask it via Q&A, and we will monitor the Q&A to provide an answer already. Okay, so Mariusz, I'll give it on to you.
Okay, so now you know how document intelligence works, and now I would like to tell you shortly about how we created this project. I would like to tell you about architecture, and I will tell you shortly about the Python code, which was created for the client. So let me walk you through this architecture designed to efficiently process emails and attachments through automation, leveraging cloud-native services for scalability and performance. So at the core of this setup is the resource group, which serves as the organizational boundary in Azure. All the project resources are grouped here, allowing us.
I think that you don't share your screen.
No? Okay. So once again, sorry, thanks. And now?
The presentation already with slideshow from current slide.
So you see my presentation? No.
Yeah, I see the presentation, but yeah,
but
not slideshow.
Yeah, I'm trying to.
Yeah, you should just click from current slide.
I'm clicking, but it doesn't work.
Okay.
Right.
So maybe I will try to.
So.
I will share and.
No. Wait a second, Paweł.
Okay.
Wait a sec. I will try this one again. No.
now still the presentation. Still the screen with.
And now?
Okay.
Can you see the architecture?
Yes, there's architecture. Yeah.
Perfect. Okay, so I said that we have, of course, the resource group, and then there's like the core of each project in Azure. Then the systems data pipelines relies on the storage account, which is divided into 3 containers. We have an input, and this is where the raw data attachments is ingested into the system. Output, here you will find the process data. So typically the results after running OCR on documents. And the last one here is like the output dynamics is the process data is transferred to the client's dedicated container in the separate storage account in the separate resource group. And then the storage is securely accessed by the Azure function through manage identity, which here eliminates the need for managing explicit credentials, ensuring a secure and seamless connection to Azure services. So we don't need to use in this case, any other connection and services. So now we have the head of the processing logic is Azure Functions app, which includes 2 key Azure functions. The first one is like the Gmail reader Azure function. This function is possible for reading emails from the client mailbox. Gmail reader function connects to one type of mailbox, clear mailbox dedicated just for this project, where emails are sent by the employees, and this is where the email from external clients are received as well. That the Gmail reader extracts the relevant data from this mailbox and passes to the next stage for processing, and our next stage is in this case OCR, where we have an output container. So we have an OCR Azure function. So once the Gmail reader extracts attachments from the email, the OCR function processes this document using OCR to extract text from PDF and to extract invoice number from the PDF. And these 2 functions are deployed within an app service plan, ensuring high availability, scalability, and the costing performance. As you can see here at the bottom, that both the Gmail and OCR Azure function are containerized using Docker. And this containerization ensures consistent environment and easier deployment. The Docker containers are stored in Azure Container Registry, which securely manages and stores these images for deployment into Azure Function App. It's the base approach, containerization, because to be honest, we have a lot of problem with the Python packages and how to connect everything. So the last thing is App Service Plan. It's responsible for managing the compute resources that run this containerized function. It automatically pulls the necessary Docker containers from the Azure Container Registry and deploys them, allowing the system to scale up and down based on the workload demands. So as you can see, we have a client email. We check if there is something new. Every 5 minutes, this Gmail user runs. Then if the new email is found, we store this email to input, then OCR function is triggered. If there is something new, email in input attachments, so OCR function runs. We save the new PDF file to output, and we save the new PDF, the same PDF, to the output dynamics container in the new storage account in the client. Here, that's everything about architecture. Now I'd like to show you something about Python, how we create this Python code. So now at the beginning we have some variables, and for me the most important is query string, which has attachment query. It means that we take just these images with attachments in emails, so nothing more is important for this function. So in the second step, we have integration with Azure Key Vault. Thanks that we get the secrets like Gmail client ID, clean secret, refresh token. We create connection string to our storage account, and we create a blob service client. Now, in the next function, refresh Gmail token, to access the Gmail account and download attachments with the OAuth2 authentication mechanism. And the refresh Gmail token function plays a critical role here. It obtains a fresh access token from Google Cloud Console for the Gmail API using the refresh token. Once we have this token, we can create the Gmail API clients using the build function, which allow us to interact with the mailbox and perform various operations, like download just attachment mail with attachments. Next, we searching Gmail for emails with attachments. Yes, so we have create refresh Gmail token. We have a search email. So next we have the search email function. This function scans the inbox for emails that meet the specific criteria. In this case, emails that contain attachments. And yes, please see the query string. It's designed to handle large mailboxes efficiently by supporting pagination. So it's allowing us to browse through multiple pages of search result if needed. Then we have we download attachments. So we have the first function, get attachment data function, retrieve these attachments. It codes the base 64 encode content of the attachments and process them for further steps. Another function, get message detail, extract detailed information from the email, including attachments, metadata, attachment ID, file name, and body. And then the last function, reverse upload blob. So this function is using to upload the files to Azure Blob Storage. By default, these files are stored in container and input. And this function also handles potential error by returning uploads if they fail, adding an extra layer of reliability. And of course we have the main function. So that's the head of the system. This is the function triggered by time-based timer. It initiates the entire workflow every 5 minutes. From fetching a new token to downloading attachment and uploading them to Azure. And then once the attachment is successfully uploaded to Azure, the email is moved to the trash in Gmail using the trash method from the Gmail API. And this ensures that only unprocessed email remain in the inbox, keeping the system clean and organized. So that's about OCR function. Now we have a Gmail function. Now we have an OCR function. So now I'm going to walk you through the solution for automating PDF processing. So this solution automatically extracts text from the PDF documents, rename the files based on the keywords, and stores them in the cloud for further use. So now we divide into how this process works. So at the beginning, we have connection to Azure Blob storage. Then we initiate OCR and PDF processing. And I would like to tell you now about EasyOCR, because we use EasyOCR package. So this library for extracting text from PDFs. This package is an incredibly effective OCR library. I recommend these packages to using. And we also use fits package from Pawel PDF. And this allows us to take PDF files and convert each page into an image, which is then passed through the OCR engine for text extraction. And now you can see some variables like zoom, here country. So here we can choose the specific text language, zoom, level, this controls the resolution at which we render each PDF page for text recognition. So it's like from for invoice for this invoice number we use the 2, but it depends of the case. Maybe 3, 4 is also good. Okay, so we need to initialize reader and math variable, and now we so the reader, like we initialize reader by installing a model for the specific language, and we download the model from EasyOCR website, and we don't want to download model every time. It's time consuming to do that. So for this project, it was better option to download and read the model from the specific folder. And this math variable, so we have we create initializer matrix that scales the render PDF page image by the specific zoom factor. So this green arrow. So then we have a main function. So when the PDF is uploaded, the system automatically opens it and processes it page by page. So we have a for loop. Each page is rendered into an image and passed to EasyOCR to extract any text that appears on the page. Yeah, so we have this, and then once the text is extracted, the system searches for specific keywords. So we have these keywords. Wait a sec. Result. Split words yet. So thanks on that, we're looking for the specific invoice number. So if we find a keyword like number, we know that we are dealing with an important piece of the information. And using this data, so we have a new number invoice. We rename the PDF with a more descriptive name that reflects the context of the file, like the invoice number. And finally, and finally, yes, we send the new PDF to the output and output dynamics container, and using the upload blob function from SDK Python packages, and create some logging info, and that's all about this code. So Pawel, we can start.
Okay, Now we will go to the second use case, which is the application we call waste. This was the application that has been created for one of the sustainability hackathon. The idea behind it was that the food waste problem is one of the widely acknowledged, and this is one of the goal which has been set by United Nations. This is the Sustainable Development Goal number 12. To decrease this issue. About the context, some of the statistics that I have provided on the slide, that was from 2019, that approximately 931 million tons of food were waste, and of this, 61% was from households, 26% from food service, and 13% from retail. So the solution that we have prepared has several features. The one was to recognize the product. So based on the mobile camera, you can recognize the product that you have, for instance, in the fridge. Then, based on these products, the recipes has been prepared using a large language model. So the most of the product can be used. It also has the second module, which was for the waste management. The waste management for recycling purposes is also sometimes challenging for the users. So the application classify these wastes, and it also estimates the expiration date if it was not provided on the box. Benefits from the application was assisting the user with reducing this food waste and improving the garbage sort. So now I think we can go to the demo of the application and how it looks like. So as you may see, we have the analyzer. We are taking a photo of the products, and we have the information of what ingredient do we have. Based on this, the two recipes has been proposed with all of the information which is required for this recipes and instruction how to do it. And the second model, so the waste module. Also, we are taking the photo of the waste, and we see the information that it's bio, so the proper bin has been choosing. Here we have the plastic. So also this has been thrown away. Okay, so I think we can go to the vision demo, which has been used for this opportunity. Also, OpenAI has been used here, but OpenAI will present in the last part of our presentation. So now let's go to the vision. Okay, as you may see, when in the Vision Studio, we have several groups of features. We have the OCR, we have the spatial analysis, face and image analysis. About the OCR, I have talked on the previous topic, so I won't deep dive into it. For the spatial analysis, we have, for instance, this is especially used for the stores, when we can count the people in an expected area. In most cases, it's calculating people in the queue, so whether the queue is not too long. We can also monitor the social distancing, as this has been introduced during the pandemic, and this was one of the things that was quite helpful. We have also detecting the faces in the images and analysis of the images. From most interesting features, we have, for example, recognize the products on shelves. This is especially useful for the stores when we want to analyze whether the products are proper from the planogram perspective. And of course, we have a lot of image analysis tools. For this area, we have two things that has been used. The first one was to take the common objects in the image. So we can put some image that we have prepared and see how the model will be working without any additional test. Okay, so we have this kind of information. As you can see, two things has been recognized, and one was recognized as fruit, and the second was recognized as food. So as you may see, some additional training of the custom model should be implemented. And we can do it using the also Vision Studio, so we can create the data set with our images, and using the Azure ML. Yeah, I will open it a different way. Azure Machine Learning. Yeah, and what we have in Azure Machine Learning is the data labeling, in which can label the products that we have on the images. Yes, and when we label these images, this will be a custom model trained on based on the images that we have provided. Okay, so now we can jump into the architecture. So Mariusz, over to you. Okay, yeah, there's you're mute.
Okay, but you can see my screen. Yes, Paweł?
Yes, I can see your screen.
Okay, cool. So now we create this application. So you can see the high-level architecture for this application, and so this architecture leverage Azure cloud services and AI models to deliver a comprehensive solution focused on ingredient recognition, waste management, and receipt suggestion. So it integrates cognitive services, machine learning models, and cloud storage. So let's break down the key components and the interaction. So at the beginning, we have a mobile application. On the front end, we have a mobile application built using Angular and Ionic, serving as the user interface. And the app provides three main functionalities. The first one, image recognition. User take a picture of the product and the system recognizes the ingredients. Waste analysis. User take a picture of waste items. The system analyzes the waste and provides waste recycling guideline and an assessment of the recycling impact. And the last one, receipt suggestion. So based on the recognized ingredients, the app suggests the potential receipt, helping users reduce food waste by using the ingredients they already have. Now, here we have Azure Cognitive Services. So when a user uploads an image, it's sent to Azure Cognitive Services. This component processes the image, provide initial recognition of the content, whether it's ingredients or waste material. So we are here about ingredient recognition model. So we talk about so this ingredient recognition model. So we recognize products. Waste recognition model here. This model identifies waste material from the waste images. And as you can see on the demo, there was like plastic, bio, glass, paper. So for the most popular most popular things to recycle. Yes. So then we are here to ingredient inventory. System is a critical component that tracks all recognized ingredients. So as you can see, we have information from model, from picture, from expiration date, and based on this, in this step, we even create a receipt suggestion based on the ingredients. So ingredient expiration date. So after recognizing the ingredients, the system calculates the expiration date. So we are using we use GPT, which help us monitor and use to do that. And thanks on that, we can helping user monitor and use food waste. And so we, as I said, we use GPT to estimate the expiration date. Then we have Azure Blob Storage here. So we have ingredients picture storage, so to store images related to recognized ingredients and for further processing and history. So each picture is stored in Azure Blob Storage. Then we have a SQL database here. So the Azure SQL database stores the recycled waste history, maintaining records of waste items users have analyzed through the system. And this helps in generating reports on recycling efforts and impact. And yeah, so we have a picture, we took a picture, we store in the blob, we use Azure OpenAI to calculate, to estimate expiration date. We save this information in SQL database, and then we can create the receipt suggestion. So here, yes. So once ingredient recognized and stored, the system utilizes data to generate receipt suggestion. And of course, everything like the backend orchestration we use function app to do all of this step. So entire backend logic is orchestrated through Azure Function, ensuring serverless execution of the task. So we using Azure Function, we connect all of these steps into one application. Now I would like to show you the example of the code for this waste. So the waste part. So as you can see, we have a variable CV model key. So once we created the model in Azure Vision, we use this model, and we got this the model from key from this model to the further processing. So at the beginning here, when the image is taken, we send the request post to the model to get the prediction. So the function, so this function will start, receive an image in the base 64 format, decodes it, and sends it to the pre-trained image classification model via post request. And the model analyzes the image to predict the type of the waste and returns the tag and its probability. Yes, so then we insert waste tab database. So inserting prediction into the database. So when the prediction is made, this function connects to Azure SQL database using PayODBC and insert the predicted waste type and its probability. Of course, along with the timestamp, thanks that this ensures that data is logged for future analysis and auditing. Oh, sorry. And the last function, we have also we have the main function. So the main function is a entry point of the Azure function. It handles incoming HTTP request. Here it has processed the image and returns the classified waste type in the JSON format. It also manages error handling to provide feedback if something goes wrong during the request process. So we had also almost the same script for ingredients recognition. Yeah, but we don't have a time to talk about all of this code. So for me, I have chosen this one. So Pawel, we can go to the next business case.
Yeah, so the last business case that we want to present to you today is reading the flow meters, and again, as very similar to the first business case with the invoices, the process of reading the information from the photos that the customers send to the organization with the information about the flow meters indications are very time consuming and prone to the error. So in this project, we have used large language model, multi-model large language model, which is very important to read the information from the flow meters images, which bring us also higher accuracy, and it's much more scalable solution, which can be used for tons of images with the flow meters. It can be the electricity flow meters, can be water flow meters, gas flow meters. It's not so important what kind of meter will be used in this solution. So now I will jump into the Azure OpenAI and show how it's done in the studio. Okay, so we are in the studio of Azure OpenAI. This is basically using any of the GPT family model, but not only this, also provides other OpenAI models such as Whisper, which is using for speech to text. But what I will focus on today is the multimodal large language model. So one of the deployment that we can choose is the GPT-4o. GPT-4o is the multimodal model. So as it's written here in start chatting, the chat playground can now see, hear, and speak. So we will use this first ability. We use the ability to see the images for providing the information. Okay, so basically what we test at the very beginning is that not building the whole application from scratch, but starting with prompting using the studio. So let's use the photo from our presentation, and please read me the indication of this meter. I'll see how it's coming. Yes, we can see we have the 9133.0. I would say that for the first digit, I'm also not sure whether it's 0 or 6. So we can also ask them to provide not only the information about the image, but also how sure it is about it. So how confident are you on this? So it changed its mind about it. I think in the wrong direction. So we'll use it in the one prompt. So not putting confusing into the large language model. So let's clear the chat. Because of course, without clearing the chat, it's answering based also on the full history of our conversation. So please read me the indication of this meter and tell about your confidence on the answer. So let's go with this meter. Okay, so as you can see, we have highly confident that it's the proper information. Of course, based on the more information from the more images, we can assess how well this prompt is doing, and if there will be some issue, if we will see, for example, that it's accurate for a high quality image and not accurate for less quality image, we can also provide some additional model which will starting assessing the quality of images before sending into Azure OpenAI. As I mentioned, currently these multimodal models can be used also in different areas. So let's go with our second example on Wasty, and we will see how it's how it will recognize the information from the image. So please provide me with the information. Oh, maybe what products are on the image. Okay, so we provide the image of the fridge. Yeah, and as you can see, we have the whole list of information. What type of products are on this image. So as you may see, also this model can be used instead of the computer vision in some use cases. Of course, the choosing between these approaches is will be highly depend on the specific use case and on the for example cost of the tokens in Azure OpenAI case, or price per service in Azure AI vision case. Okay, so I think that now we can also jump into the architecture of this solution and Python code. So Mariusz, over to you. Okay, we can see it. But you're mute.
Okay, so in this architecture, we leverage several core Azure services. So this like Azure Web App, Azure OpenAI, and Storage Account. So this solution demonstrates how cloud resources and GPT Azure OpenAI can be integrated to process flow meter image and retrieve data, media content, like the meta content from image. So at the beginning, on the front of the architecture, we have a Azure Web App. So users interact with the system through a web interface. So these users could be uploading electric meter to retrieve consumption from the flow meter. And I will show you this platform in the next slide. Then we have the user interface is powered by Azure Web App, which and we chose to build this power to application, we have chosen the Streamlit. Is a framework to offer a seamless and user-friendly interaction layer. So the web app handles user input, routing it to the appropriate service, to Azure OpenAI, the storage account, for create the response for the user, for the client. So now we have a query from the users. We have a web app. We retrieve so then we retrieve images examples, because we generate examples using a few shot prompting in this case, because we have got the image from the client, and the image was in not good quality, as I can say. And so to improve the response from the Azure OpenAI, we use few shot prompting approach. So when there was a query from the user, we retrieve a couple of images to create few shot prompting, and we get the content of the data from these images to web app. So then we create one prompt with image from the client, from the user, plus few shot prompting, and then we ask LLM about the consumption. And then LLM, so our GPT for Omni, return information about the consumption based on the flow meter. Of course, we have a use the Azure Key Vault, and there is like the icon of the resource group, and this is the user interface of our application. So as you can see on the left side, we provide an image generated by GPT-4 Omni. That is our logo of our application. The right side features is a header application for meter reading. And the file upload section in the here below allows user to easily drag and drop or browse for the emitter. So there was like the application accept the image in the JPG or PNG format. So now we have some code in Python. Like each Python code, now we have import libraries. Then we create a configure Azure OpenAI client. So from the config file, we have some API key, AP version, Azure endpoint. Then we set up a streamlined layout. So as you can see, this application is very easy to build in Python using Streamlit. So we have a display image in the left column because we divide our application into columns. So the left one has an image, and the right one has a display header in the right column in the center in this column. Then we have a session state setup. Okay, and then we have image upload section and displaying uploaded image because we can select the image. Then when we uploaded the image, the application show us the current image, and then we can be sure that we chose the correct one. So then we create the image, the button for image analysis. And here in the image analysis step, we send this image in the base 64 format to analyze image with GPT-4 function. And we get some results like we get some information like result prompt tokens, cost, completion tokens, cost, and total cost. It was very important for our clients to calculate cost and tokens per one image. So based on this information, after iteration, we have like for a couple of hundred images, we create some statistics about cost per image, about tokens, and so on, so on. And the last part of this UI of the Streamlit application, we have the wrong. It shouldn't be image analysis button, but it's a real-time analyzing. So we have information about. We get the information about the result, about the consumption. So the application show us the information that life is meta reading, and that's we fill this result with information from GPT. Okay, and now it's some. I would like to show you the main function to analyze this image, each image, how to send to GPT to Azure OpenAI. So. So here we retrieving images and data like and create examples for GPT-4o. So we have a path container path connection string. We get the specific the dedicated images for few shot prompting. Then we have a create example function. So we create examples for few-shot prompting, and we use these examples variable here in creating the message, the whole message for GPT-4o. So we have a creating header for the request, of course. We create a system message, and we create user message. It's very important, and maybe I should tell you that it's very important to have a message in proper way, because, for example, for O, GPT-4o has a different format than GPT-4. Yes, so or maybe for vision. So it should be like system message examples user message in few-shot prompting. And for example, for GPT vision, for vision, I don't remember now correctly, but we can check in the Azure OpenAI Studio. It's like the system message, like the user message, system message example. So it's a little bit different. So so the message is different based on it's different for each, maybe not for each, but both for the couple of different GPT version. So we have we created system and user message. We have a message. We create the whole message, and we create a request payload where you can find information of temperature, top P, max tokens, and then we convert this payload to list and sending to request to GPT-4o. And we get the image about, we get the result about image text. So image text means the consumption from the flow meter, prompt tokens, prompt cost, completion token cost, and total cost, and return this whole information. Okay, so that's all from our side.
Thank you for presentation. And do we have any questions? We'll give, for now, we have no questions in Q&A chat. We'll wait for a minute or two to see if somebody will write something. So yeah, let's wait for a minute. Yeah, while we wait, I want to thank you, both of you, for taking your part in DSC DACH this year, and thank you for the great presentation. I hope everybody learned something. I really liked this presentation a lot, and yeah, thank you so much once again.
Thank you very much.
Thank you. Thank you for your attention.
It looks like we don't have any questions, so I think we can end this webinar. So yeah, see you at the conference and maybe at some other time as well. See you.
Yeah.
Bye-bye.
See you. Bye-bye.
Thank you. Bye-bye.